I'm Anil Kumar, and here is an identity for us to prove. The question here is determine the non-permissible values of x and prove the identity. Now, for non-permissible values, denominator cannot be 0. So you have to look for those. Second, cosecant x and cotangent x, they are not defined when cos x is 0, right? So those gives you some more values which will be restrictions on this particular function. So what is important to understand here is that for any trigonometric identity, there are some non-permitted values. Apart from those values, the identity should be true for all the values. So that is the whole concept, right? So let us, what we will do is we'll write down the non-permissible values later, but we'll first solve it. Because when we are going to solve this particular identity, we'll come across zeros in the denominator, which will lead to non-permitted values, right? Now solving, we could follow a couple of methods. One of the method is break up sine and cosine, cosecants and tangents in terms of sine and cosine. That is one particular method which could be adopted. The other one is use the Pythagorean identity for the reciprocal functions, right? So let me remind you what Pythagorean identity relates cosecant and cotangent. It is 1 plus cot square x is equals to cosecant square x. So that is the identity which relates these trigonometric expressions, correct? Trigonometric ratios. So if I rearrange, since I have cosecant x minus cot x, so I could rearrange and I can say 1 is equals to cosecant square x minus cot square x. I'm just giving you these ideas so that it helps you to understand how to solve such identities. You get the idea, right? Now, if you know this, then what we can do is we can very easily solve this identity. You could start from left side or from right side to solve it. Let me show you how. Let's begin from the left side in this case. So left side is equal to 1 over cosecant x plus cot x. What I will do here is I'll kind of multiply and divide by one term. And you know what, right? Do you know? What term should I multiply and divide by to get this answer? So I'll multiply, I need this, right? So I'll multiply by cosecant x minus cot x. And also divide by cosecant x minus cot x, correct? So when I do that, in the numerator, I get what I need, which is cosecant x minus cot x. And in the denominator, this is a plus b times a minus b. So I get a square minus b square. That is cosecant square x minus cot square x, which we know is 1. Do you see this equation? Which we know is 1. And therefore, this is equals to cosecant x minus cot x, and that is right side. So whenever we have to prove an identity, we always prove left side to equals to right side. And it is preferred to begin from one side and land up in the other, right? So that is how you could easily do this question, correct? Now, let us adopt the second method, which is a very popular method. So we'll again start with the left side. You could start from any side in this particular case. Let's begin with the left side. Now, and we'll write cosecant and cotangent in terms of sine and cosine. So what we have here is 1 over, cosecant is 1 over sine x, right? So let me write this as 1 over sine x plus cos x over sine x, cos x over sine x, right? Now that gives you restrictions. The restrictions are that sine x is not equal to 0, right? So it's in the denominator, it cannot be 0. So one of the restrictions which we see straight away is sine x is not equal to 0. So we'll write for those later, okay? Now we can take common denominator as sine x, which is indeed a common denominator. So we get 1 plus cos x in the denominator and sine x in goes upright. So we could write this as sine x over 1 plus cos x. Right? So that is what we get from this particular expression. Now what we need here is cosecant x minus cotangent x. Now how do we get that? We can actually again rationalize. That means we could multiply by 1 minus cos x. So if I do that 1 minus cos x, then I get here, so let me do that step here because we run out of space otherwise. So what I will do, I'll kind of do the same step here. But this time I'll multiply and divide by 1 minus cos x and divide by 1 minus cos x. That is 1. So you can always multiply and divide by these terms. Is that okay? Because we need difference of two terms. So we need something like this. So if you do that, then what do you get? You get sine x minus sine x cosine x divided by 1 plus cos x times 1 minus cos x will be 1 square, which is 1, minus cos square x. You get the idea, right? Now what is cos square x? Cos square x is sine square x. So we could write this as sine x minus sine x cosine x divided by sine square x. Correct? Sine square x. And now individually, sine x divided by sine square x is 1 over sine x minus, if you do this ratio, sine x cancel, you get cos x over sine x. Is that okay? So that is what you get, which is your right side, right? So which is equal to, because we are running out of space, so I'll just continue here. So 1 over sine x is cosecant x minus cot x, which is equals to the right side. Is that okay? So you could do this way also, but my preference is if you have terms in cosecant and cot, there is no need to write them in terms of sine and cosine. Do this method, right? So that is the preferred method. You should know your Pythagorean identities with reciprocal trigonometric ratios, correct? Now we did write no permitted values as sin x not equal to 0, but do you know when sin x is 0? For that is the graph for sin x, right? So let me just sketch one graph here and write on the restrictions just in between. So that is the graph for sin x, and we say x is not equal to 0, pi and 2 pi. These are the three values for which sin x is 0, right? So within interval 0 to 2 pi, these are the values, but in general it will be n pi, right, where n belongs to integers. You get the idea. So these are non-permissible values for our expression. Is that okay? So that is how you're going to answer this particular question. But I hope you have understood the basic concept. So very important question. Go through it once again and see how to do such questions. And as I said earlier, better method is the one where in this particular case you are not converting to sine and cosine. I hope that helps. Thank you.